Hello, Math Fairy here. I'm going to start you off with a song, and you'll see it has something to do with math. All right, here we go.
Math is everywhere.
Math is everywhere.
Math is everywhere.
Math is everywhere.
There goes math again.
When you organize the toys in your room,
There goes math again.
when you look to the sky, start counting balloons.
There goes math again.
When you realize you have half a cup
There goes math again.
of yummy hot chocolate, so fill it up.
Math is everywhere.
Math is everywhere.
Math is everywhere.
Math is everywhere.
There goes math again.
There it goes again.
Difference between a circle and a square,
There goes math again.
or measuring a panda bear.
There
Aw,
goes math
cute.
again.
The amount of coins in your piggy bank.
There goes math again.
It's always math that you have to thank.
Math is everywhere. Math is everywhere. It's everywhere, everyone. Ba-da-bum. Yeah, that's that. Math is everywhere. Math is everywhere. Yeah, it is. So, we're going to look and see a picture that I took, because I could pretty much just keep taking pictures all day, every day, because math is everywhere. So, I want you to take a look at this picture. That's from Gunnison, Colorado. And you may know right where it is. It is actually at Western, the college that happens to be in Gunnison, Colorado. It's the most beautiful college ever, and it's an awesome place to be a student, as I went there for college. Got my math degree there. This picture, I looked at it, I took the picture of it, and I was like, I happened to be walking through Western, and I was like, man, I just love this one. So I want you to pause the video and on a piece of paper or something to write on, get something that you can write on, and write what comes to you math-wise when you see this. Like, what kind of mathy things? Write them down. And then press play on the video, and you'll be able to see what I was thinking. Okay? Because I'm going to start. So I saw this, and I'm like, windows! There are so many windows. Holy moly. Windows, windows, windows. And this one, they are just so neatly placed, right? So my question to you, and my question to myself as I was passing by this dormitory, was how many windows are on this side of the dorm? How many windows are they going to have to wash? A lot. So how many is that? So before you pause the video and try and figure this out yourself, we have to establish that this right here is considered one window, okay? So I want you to take some time and try to find at least two different ways, at least two, of figuring out how you could count up these windows without counting them one by one by one by one. So instead of just going, well, that's 1, 2, 3, 4, like that, you have a different way of counting it, okay? All right, pause the video, make your mathematical equations, come up with how many windows there are, and see if you get two different ways, but yet they're the same answer. They should be the same answer, okay? All right, here I go. Here was one way that I thought about it. So I loved how right here I had a set of 2. I didn't just have a set of 1. So when I looked at this guy right here, that was just 3 windows. It was just one set of 3 windows here. It's pretty much a 1 by 3. Okay? So I have a set of 3 here. And now do I have a set of 3 here? No. I actually have double that. So I don't just have a set of 3. I have a set of 3 plus 3. So I could say 3 and 3. if I wanted to keep going with 3s like that. Well, how many 3s am I going to have all the way down? Well, that's where I'm going to say, well, I have 2 sets of 3s here, 2 sets of 3s here, 2 sets of 3s here, 2, 2, and then just 1. So I could write out a big long statement here. I have a 1 by 3 plus 2 sets of 3 windows plus 2 more 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 sets of 3 windows. That's a lot of times to write a 2 by 3 or 2 sets of 3 windows. So instead of doing all of that, I'm just going to say, well, we have 2 sets of 3. How many times? Well, it happened 1. It happened 2, 3, 4, 5. It happened 5 times. So I'm going to say this happened 5 times. Okay, that way I don't have to write it 5 times. And then I had 1 more set of 3 at the end. Okay, so if I write this in one long, nice mathematical statement, I would have a 1 by 3, so I'm writing it here at the bottom, a 1 by 3 plus 5 sets of 2 sets of 3 windows there in the middle, plus 1 more set of 3 there at the end. Okay? And when I add this all up and do that multiplication, what will I end up getting? How many total windows? So here I have this equaling 3. This is just 3. But in the middle here, I have 5 times what? Well, 2 groups of 3 windows would be 6. And you can see that right here, 6 windows. Now 5 groups of 6, or 5 times 6, is equal to 30. So now all I have to do is add my 30 with my 3 and my 3, and I'll get 36. So this window picture produced just such a beautiful equation. Oh, love it. Math is everywhere. Now that was just one way, my first way of thinking about it. Now let's try and think about it another way. So I'm going to erase all my beautiful work, my work. Okay, and I'm okay with that because I'm going to find another way to get an answer of 36 windows. So another way is to just say, okay, I see I have 1, 2, 3, 4, 5, 6, 7. I have 7 columns of windows, right? Each one with a little bit of space in between. 7 columns of windows. Now in each of those columns, how many windows are there? Well, that's where I run into a problem because some of them have 3 and some of them have 6. But let's just say I'm going to round up for some of them. And I'm just going to say, well, I'm going to say this is 6. Well, that is 6. And I have 6 here, I have 6 here, I have 6 here, and I have 6 here. But what if I just say, well, I'm going to say there are 6 there and there are 6 there. And you're like, wait, they're not 6, there's only 3. Well, just hold on. I'm going to write, well, what if I did have 7 columns of 6? Then I would have how many total windows? Well, 7 times 6 is 42. But I would need to take out, so I'm going to subtract off how much? Well, I put too many windows in this one just so I could keep it as one nice multiplication. I would need to take out 3 here, and I would need to take out 3 here. So I would need to take off 2 sets of 3, which is actually 2 sets of 3 is equal to 6. Because I don't need 3 of the windows, because remember, 3 of them are missing in this one, or they didn't put them there, right? They're not there, which means I don't want the 6, right? I only want 3. So I'm going to take out one of those 3, and I'm going to take out 3 over here. So now if I subtract that 6 from 42, well, what would I be at? if I'm at 42 and I go back 6 minus 6. Well, it's easier for me in my head if I just go back 2 first, because then I'm at a very lovely number of 40. But I need to go back 6. So if I go back 2, how many more do I still have to go back? I still have to go back 1, 2, 3, 4, right? I'd still have to go back 4 to be in a total of 6. So if I go back 4 from 40, 39, 38, 37, 36, I'm at 36, which is what we got before. Awesomeness! Math is everywhere. Math is everywhere. Just notice it. Math is everywhere. And Windows especially are all over the place. So hopefully you found at least 2 ways, and were your ways the same as mine? Or maybe they were a little different. All right, keep it up, guys. See you again soon. And notice, again, that math is everywhere.